to another Maker Cut video. Before we get started, please remember to subscribe to the channel and click the bell for notifications on when we release our next video. We wanted to give a shout out to Tech Guy for requesting a origin settings video in our comments. You can stop by the Tech Guy channel to see what's going on over there. The link is in the description below. This video is on setting the origin for jobs in Autolaser for machines that use the Topwisdom controller. Autolaser and the Topwisdom controller have multiple positions that can be referenced when setting up a job. Each are set in Autolaser. One of these settings should never be changed after it's set, and the others are set based on the job you're doing and the geometry that you have. So let's start with the one that should never be changed, the machine reset position. This parameter is accessed through the machine info button, and then you click on the format parameter button. And here you see the machine reset position. Left top, top right, left bottom, right bottom. These are all in reference to standing and looking at the machine from the front. So left top is the furthest point of the laser machine from your perspective at the front of the machine. On the left hand side, that is considered the top of the machine or the top of the bed. The right top is the furthest point on the bed from the front of the machine on the right hand side, and the bottom is converse of that. It is the closest to the front of the machine. So if you were to tilt the bed up on its edge, it would be the top would be the furthest point, and the bottom would be the lowest point of the bed. It also gives that same correlation to, as you're looking at the software, the top of the bed is at the top of your screen. The bottom of the bed is at the bottom of the screen. This setting should never be changed. It should be set as the same as machine. How do you know what the machine reset position is? So top right is where we have our machine set. The machine reset position should be set for the corner that the head moves to when you first turn the machine on. And when I say turn the machine on, you turn the controller on, because they are two separate operations. It's also where the limit switches are located. It's most likely the top right corner of the machine, or the furthest corner from you while facing the machine on the right hand side. The next origin is the pitch dot, which has 9 locations. You can see here, we can move this around. I had it set here because I was using the rotary functions on my machine. There are 9 locations, and we will set the pitch dot for each location and then send a job over to the machine and see what it does. Below the pitch dot, you see process positioning. It's a drop-down list. We'll go through each of these as well and send a job to the laser and see what it does. The last origin is the start position, which is set on the geometry in Autolaser. So with this square, each one of these dots represents a possible start position, and we'll show you how to set it and the effect that it has on how and where the laser starts cutting or engraving. For most of this, we'll just use the red dot to show how the laser head moves in relation to the bed. So you can see here I've drawn a 50 by 50 rectangle. I've set it at 0, 0, and this is in reference to the top left hand corner, which I have typically used as my origin. The machine origin, where the limit switches are, is 900 and 0. So let's go over the machine info, format parameters, and right now we can see that the pitch dot is in the top right hand position, and our processing position is current location. Now in the previous snippet you saw the machine reset and where it went to, so we know this is top right. We know the size of our bed, which is 900 by 600. So we're going to say OK to this. We're going to close that out. We will download this job to the machine. and let's see what it does. Alright, so now we're going to move our pitch dot over to the next reference point. So we're going to do the four corners first, then we'll run through the centers and the so we can see that that definitely changed the direction of the operation. So let's switch this down to the bottom left-hand corner. Okay, now that we've processed that, and I'll explain the additional movements in it here in a couple minutes, but we'll switch to the bottom right-hand corner. Alright, now let's move to the center dot. I think this one will be a little telling as well. There is a purpose behind those extra movements, and it ties in to the geometry, and we'll explain that here shortly. But let's run this through the machine, see what we get. I think everybody's starting to get the pictures to what the pitch dot is all about. So let's see about the center. Okay, so now I'm going to let the cat out of the bag and explain why the machine does what it does. It's perceived to be extra movement. So the start position is typically in the top left-hand corner of the geometry. So while you can change that, that's why when you see it supposed to be starting in the center, it moves up to this corner and then moves around. When we were starting in the bottom, it moved to the top, moved around, completed the geometry, and then moved back to the pitch point. So let's change this start position to here, and we'll run the same pitch point, which is in the center, and you'll see how the machine reacts differently. So you can see that the actual start position that you mark makes a difference as far as where it starts on the geometry. This can also change your order of operations, but it is relevant specifically if you want something to be repeatable. This is where it ties into having templates and making sure that you don't change these based on how you originally did the project. So now we're going to move the pitch dot back up to the top left-hand side, and we're going to try mechanical origin. I'm also going to change the starting position. Not quite what you're expecting, right? Well, let's look at why it did that. We set the processing position to mechanical origin, which is the top right. We also set the pitch dot in the top left-hand side, which says, okay, your starting point is here, but we got an out of range error. And why is that? Because if we're going, we have the pitch dot here, we have the starting point here, and we go to the mechanical origin, which is here, it cannot, the head cannot physically go any further than the mechanical origin, which is why we got the out of range error. So let's change this. Let's change our pitch dot to here. Say OK. And we'll leave our starting point. Let's see if it does the same thing. Okay, so that was better. We didn't get out of range. It's because our pitch dot is set to the top right. We went to our mechanical origin of the machine, and you saw that the head came all the way over here and then moved back 50 millimeters to the start point, and then it drew the square. Even though it was all the way over here, it drew the square and then went back to its origin, soft set on the machine. So if we use mechanical origin, no matter where our soft set origin is, it's going to go, the machine's going to go all the way up to the mechanical origin where it knows the max limits are, and for the x-axis, and it's going to start there, and it'll back off depending on the pitch. If we set this pitch here, we would get an out of range. Why is that? Because then it would be trying to move further towards the back of the machine or towards the top, and it cannot do that because it's already at 0. So if you're going to use mechanical origin, make sure that you set your pitch dot in such a fashion. Doesn't matter where your start is, it matters where your pitch dot is. And that pitch dot has to be set where the head can move from the mechanical origin. Manual key positioning and current location have the same effect, because the current location, it seems, is going off of what the current origin is, not where the head is currently located. So, last one. Let's check the absolute coordinates. Let's see what this does. Now, in theory, this should put it to 0, 0, and then draw the box. So we should see it go up to the top left-hand corner and draw our box. Let's see if it does it. I hope you're finding this helpful. So we can see that using absolute coordinates puts it at the start location and the absolute coordinates of where the geometry is in relation to the bed. So if it's at 0, 0, it's going to go up to 0, 0. Now this is good for repeatability. I haven't used this much because I didn't really think of having a need for it, because I do draw templates. But if you wanted to ensure that all your geometry goes to a very specific place every single time for, say, cutting out leather or fabric, you can set it to absolute coordinates, and it will, no matter what the origin is, go to that location and start the cut or engraving from there, which is a good thing. That'll also allow you to define your geometry very well, so that your layouts are much more precise and your machine is predictable instead of being, for lack of a better term, just kind of ad hoc. Thanks again to Tech Guy for suggesting this video subject. We hope that it has been helpful for you. We hope you have a wonderful day. Don't forget to subscribe and click the bell for notifications or when we release our next video. Have a wonderful day.